Machining is a manufacturing process that involves removing materials from a workpiece using cutting tools, and converting it into the shape you desire. In machining, we use several operations in sequence, to achieve the best results. These operations are drilling, milling, and turning. Using Delmia machining solutions, we can program tool paths, and control the machine tools, in the context of the virtual machine tool model. We will create and validate the tool path, in the milling machining app, from manufacturing a forging die of a connecting rod. The machining strategy for die design will depend on the surface finish, and the roughness required for the component. This starts with studying the drawing of the connecting rod for the required quality, such as surface roughness, and dimensional tolerances. Since we are looking at machining a hardened material, here, we will have to use a 4-step machining strategy for manufacturing the forging die, that combines removing rough stock, semi-finishing, and finishing operations. We will start with the rough stock for the mold. Using roughing we will remove material from rough stock in bigger layers. Then, we will use the Z-level operation to remove the material from the vertical contours of the part. Later, we will use the contour-driven operation to remove the material from the horizontal contours of the part. Finally, to achieve the desired surface roughness and quality, we will use the sweeping operation. Let us see how to execute the steps using the milling machining app. As per our machining strategy, we will first use the roughing operation to rough machine a part in horizontal planes. With the roughing operation, the material will be removed in one or several cuts along the radial and axial directions. With the PPR context open, we will switch to the milling machining app using the south quadrant of the compass. In the PPR context, we have a machining cell, under which the rough stock for machining, the machine that will be used, and tools for different machining operations are listed. We will select the roughing icon from the surface machining section and then click Manufacturing Program from the Activities Process Tree browser. First, we will select the part to be machined. Now, we will select the imposed planes. We will define the offset values. It helps the roughing operation to recognize the input stock automatically. Next, we will define the strategy parameters, such as machining tolerance, tool diameter ratio, and the maximum depth of cut. After defining the strategy parameters, we will select the tool. Upon selection, the tool name and its properties are displayed in the dialog box. We will specify the feed rate and spindle speed. We will now define the pre- or post-motion macro. Finally, we will compute and replay the tool path. We will click OK to save the operation. All machining operations are created and saved in the Activities Process Tree immersive browser. We will now define the Z-level operation. Z-level operation is a finishing or semi-finishing operation. Click the Z-level operation icon from Surface Machining section. First, we will select the part to be machined. We will restrict the machining area by defining a limiting contour. Similar to the roughing operation, we will define offsets, strategy parameters, and then select the tool. we will specify the feed rate and spindle speed. Then select and define the macros. Compute, replay the toolpath, and save the Z-level operation. Next, we will create a contour-driven operation. It is an operation in which the tool is driven along a contour, while respecting user-defined geometric limitations and machining strategy parameters. Click the contour-driven icon from the surface machining section, and from the activities process tree, select the Z-level operation created earlier. First, we will select the part to be machined. Next, we will select the contours while defining the strategy parameters. We will select a different tool, as the operation creates a finer level of finishing. Specify the feed rate, spindle speed, and compute the tool path. Save the contour-driven operation. The final step of defining the machining tool path is creating a sweeping operation. Sweeping operation generates a tool path in vertical parallel planes. The tool can make passes along the surface of any contour, making a finished cut. Click the sweeping icon from the surface machining section, and select the earlier created contour-driven operation. From the activities process tree, we will define the sweeping contour by selecting a face. Define the required parameters. Compute and save the tool path. Finally, we will validate the tool path by using the 3D Experience Player. Select the manufacturing program and material removal mode from activities process tree. Click play in the 3D compass. This allows us to analyze and validate the defined machining strategy. We can analyze the material removal by the machining operations and compare it with the required material removal as per the design of the part. In addition, we can also check for clashes between the tool and the part. It helps to optimize the process.